Hello viewers, in today's class we are going to discuss one important and very conceptual problem from definite integrals involving the signum function and the greatest integer function, right? So this problem is going to be very useful for the beginners, and here we have to evaluate the integral from minus 1 to 1, and we have the integrand signum of x divided by greatest integer of x minus 1, right? So here we see that the integrand consists of signum function and the greatest integer function, right? So in the numerator we have the signum function, and in the denominator we have the greatest integer function, right? So let us call this integral as I, right? Now see, here we have to evaluate the integral from minus 1 to 1, right? So here we have minus 1 and here we have 1 on the real number line, right? Now see, whenever we come across with the greatest integer function, our prime objective is to search for integers, right? And here the limits within the limits of integration, that is minus 1 and 1, we have the integer 0, right? So 0 is the point where we split this integral into two parts, right? So now we can write I as I1 plus I2, right? So we'll solve this integral by splitting this integral into two parts. One is from minus 1 to 0 and the other is from 0 to 1, right? So here I1 is from minus 1 to 0, right? From minus 1 to 0, and we have signum of x divided by greatest integer of x minus 1, right? And I2 is from 0 to 1, right? So here we have 0 to 1 signum of x divided by greatest integer of x minus 1, right? So now we have two integrals to solve, right? So now in order to solve these two integrals, let us first take the definition of signum function, right? Now see, signum of x is defined like this, that is signum of x takes the value plus 1 whenever x is greater than 0, and signum of x takes the value 0 whenever x is 0, and signum of x is minus 1 when x is less than 0, right? Now see, in the first integral, the value of the limits vary from minus 1 to 0, right? So x belongs to the interval minus 1 to 0, or we can write x greater than minus 1 and less than 0, right? So here minus 1 to 0, all the values of x are negative, right? That is x is less than 0. So when x is less than 0, signum of x should be equal to minus 1, right? So here we can replace this signum of x by minus 1, right? Now in the second integral, the limits of integration vary from 0 to 1. So x belongs to the interval 0 to 1, right? Or we can write x greater than 0 but less than 1. So here when x belongs to 0 to 1, all the values of x are positive, right? That is x is greater than 0. So when x is greater than 0, signum of x takes the value plus 1, right? So here signum of x will be replaced by positive 1, right? So now these two integrals can be rewritten as minus 1 to 0. Here we have minus 1 over greatest integer of x minus 1 dx plus integral from 0 to 1, and here we have plus 1 over greatest integer of x minus 1 dx, right? So now we have to take care of this greatest integer function which appears in the denominators of both the integrals, right? So now see in this integral, that is the first integral I1, we see that x it lies between minus 1 and 0, minus 1 and 0, right? And see, we need to find out x minus 1. So what we will do, we'll subtract 1 throughout in this inequality. So we get minus 1, and here we have x minus 1, and here we have 0 minus 1, right? So we have minus 2, and here we have x minus 1, and here we have minus 1, right? So we see that this x minus 1, it lies between minus 2 and minus 1, right? So if we have the real number line, here we have minus 2, here we have minus 1, then we have 0, and here we have 1, and then we have 2, right? So x minus 1, it lies between minus 2 and minus 1. So what is the greatest integer of x minus 1? So the greatest integer of x minus 1 should be equal to minus 2, right? So whatever value of x minus 1 which lies between minus 2 and minus 1, the greatest integer of that value, that is x minus 1, should be equal to minus 2, right? Now in the second integral, we have the limits, that is x lies between 0 and 1, 0 and 1. So to get x minus 1, we subtract 1 throughout this inequality. So we'll get 0 minus 1, then here we have x minus 1, then we have 1 minus 1, right? So 0 minus 1 is minus 1, here we have x minus 1, and here we have 0. So we see that now x minus 1 lies between minus 1 and 0. So the greatest integer of x minus 1 should be equal to minus 1, right? So this is an important concept here. So now this integral I can be written as integral from minus 1 to 0. Here we have minus 1, and then we have greatest integer of x minus 1 is minus 2 dx, and then we have 0 to 1, 0 to 1, and we have plus 1, and in the denominator we have greatest integer of x minus 1 as minus 1, right? And here we have dx. So now we have two simple integrals. So I can be written as here minus and minus get cancelled. We can take half outside the integral. We have minus 1 to 0 dx, and here we can take a negative sign outside, so we have 0 to 1, and we have here simply dx, right? So we have now half, the integral dx is x, so we have x, limits are from minus 1 to 0, then we have the integral dx here, and x, and the limits are from 0 to 1, right? Now let us substitute the limits and we'll take the difference. So we have first 0 here, then we have minus 1, so we have here a minus of minus 1, right? And here we have 1 minus 0, and now we have half, this is 0 plus 1, and here 1 minus 0 is 1, so we have 1. So half times 1 is half, minus 1, then we have half minus 1 is minus half, right? So viewers, the value of this integral is equal to minus half, right? So this is how we can solve these type of definite integrals involving the important functions like signum function and the greatest integer function.